Let's go to the second slide. Okay, ladies and gentlemen, just now the E, for this software, the E, we can't follow the E because the E, didn't give any effect of the, collision. So now I share to the screen first. Okay, the second slide, we notice that, for the collision, same thing. If the collision is perfectly elastic collision, that means that after collision, the speed will difference, and they will move separately. Either, that means that the speed will change. Now, we look at the next slide. Ladies and gentlemen, we look at here, mass A, mass B. For the collision of, after collision, the speed will change, right? But you notice or not, there will be a little bit difference of the total momentum. Sorry. So this means that there will be the total kinetic energy. So this is the kinetic energy. The kinetic energy will change. If the kinetic energy is changed, that means that not perfectly elastic collision. Here, we look at that. If the coefficient is equal to 1. So that means that after collision, there still be the step. So now for this slide, for the kinetic energy, yes, we can use the C. This C effect here. So now if the E is equal to 0, what is the meaning? That means that after collision, they combine and move together less than. That means that if less than 1, it will be inelastic collision. So if there is 0, that means that the speed after collision, E is less than 1. If E is equal to 1, that means that after collision, they will move separately. Total, you look at the total before, after, the total kinetic energy are conserved, are equal. If any of them 0.2, notice or not, there will be difference of the final speed. Although they are moved with separately, we cannot say that they can be elastic collision, but it's not perfectly elastic collision. If 0.4, still with the difference in the kinetic energy. 0.6, you see, if 0.8, all of them with the difference kinetic energy, right? Just if the coefficient of the restitution is equal to 1 before collision and after collision are equal. So you notice that they will be slightly changed, right? That means that this is during collision. During collision, that means that they will reduce and increase back, restore back. But okay, before collision, the total kinetic energy and the total kinetic after collision are equal. So we said that this is perfectly elastic collision. Okay, so this means that this should be like, let me check for a while. Yeah, this theory. If equal to 1 is the elastic collision. Let me check with the reference book a while. Okay, so later I go through. So now, YE will less than 1 temporary. Okay, so that means that will less. Okay, Yongwei, you means that the green color, the curve or the after? Yongwei, open, switch on your mic.
Yes, teacher.
Which part you ask? Is it the curve part you ask?
Yes.
Okay, so the kinetic energy reduced because the process of collision, the process of the exchange of the kinetic energy, or we call that is a transferring of the momentum. Okay, so during collision, the momentum transfer each other. So that means that during the transfer of the momentum, the kinetic energy will change. Okay, so that means that there some easiest we said that some of the energy is lost during the collision. Okay, loss of the kinetic energy, but at the end it will restore back. Don't worry. Okay. Okay, now we go to the question. Let's. Okay, let's go to the question for the lesson 9, inelastic collision. Now, in the inelastic collision, we notice that this is the velocity time graph for an inelastic collision of a moving 3 kg truck and a stationary 1 kg truck. Okay, so it's the sum of the velocity the same before and after the collision. Is it the sum of the velocities? Okay, so this means that the velocity equal not sum. So from here, A, we notice that before collision, U1 plus U2 is equal to how much? U1 plus U2. U1 2 plus 0 equal to 2 ms negative 1. After collision, okay, V1 plus V2, that means that, okay, what will be the V? So we notice that V1 plus V2 is equal to 1 plus, okay, final 1.5, 1.5. Okay, so that means that after collision, it is 1.5 plus 1.5. So that means equal to 3 ms negative 1. So is the sum of the velocity the same? The answer, no. Why? Because before collision is 2, after collision is 3. And B, use the formula of momentum. Mass equal to velocity to work out. Okay, 1. The momentum of each track before collision. Okay, before collision, here we want to find the momentum of each track before collision, the total momentum of the track before the collision, the momentum of each track after the collision, the momentum of the track. Okay, total momentum of the track after the collision. Okay, let's say for M1 and M2, the red color show that this velocity show the elasticity of a moving 3 kg truck, okay, and a stationary 1 kg truck. So that means for red one, before collision, okay, if we wish to find the before collision, that means that M1, U1, okay. So for the truck, 3 kg truck, P before is equal to M1 U1. So that means 3 times 2 equal to 6 kg ms negative 1. Okay. For P, 3 kg truck P after. Momentum after will be 3 M1 V1. So that means 3 kg times with 1.5. Okay, so there is 4.5 kg ms negative 1. Okay, and for the 1 kg truck, P before equal to M1 M2 U2. So that means that it will be 1 times 0 equal to 0 ms negative 1. P after is equal to how much? M2 V2. That means 1 times with V2, 1.5. So it will be 1.5 ms negative 1. Zero kg ms negative 1, 1.5 kg ms negative 1, yeah, the unit. So that means that total momentum before P total before will be 6 plus 0. So it will be 6 kg ms negative 1. P total after is equal to how much? That means 4.5 plus with 1.5. So equal to 6 kg ms negative 1. So total momentum before collision equal to the total momentum after collision. Okay, now we look at the question. What's the question asked? Okay, for 1, 2, 3, 4, B, we already solved, right? So C are the total momentum of the same before and after. So that means that the answer for C, yes. How about D? Which of the equation was conserved, velocity or momentum? So it is total momentum. Don't write momentum only, total momentum. And calculate the total kinetic energy before and after collision. If the total kinetic before and after collision, this means that if we wish to find the now kinetic energy before collision, E K total equal to 1/2 m1 u1 squared plus 1/2 m2 u2 squared. Okay, so it will be 1/2 m1 3 times 2 squared plus with 1/2 m1 0 squared. So that means that we get that it will be 6 joule. E K. Okay. So okay, Cik Ching dah masuk ke Cik Ching? Cik Ching dah sampai sini ke? Okay, baik. Okay, EK is equal to 1/2 m1 v1 squared plus 1/2 m2 v2 squared. So this means that 1/2 3 times 1.5 squared plus with 1/2 mass 1.5 squared. So that means that we get that it will be 4.5 joule. So as a conclusion, what can we conclude? Okay, 6 joule and 4.5 joule. This means that conclusion. I write here. Sum of the energy lost. Okay, so total conserved. If not conserved, it is the collision. It is that means that this is inelastic collision. Okay, get it? Okay, bagi kalau bagi pelajar Cik Ching yang lambat masuk, so please, okay, please screenshot ya, or later you refer to your friends. Okay, now I wish to go to the next worksheet. Let me switch on the. Okay, now let's go to the worksheet. Okay, so this is the next worksheet is the lesson number 10, yeah, perfectly elastic collision. For the perfectly elastic collision, here we notice that mass before, okay, mass is 3 kg and moving, okay, both of them with 3 kg. Okay, 2 3 kg truck moving with initial velocity 4 and -4. That means that opposite direction with the same magnitude. Now, what is the principle of conservation of momentum? If we wish to explain the principle of conservation of momentum, that means that A, we write that. Okay, I write somewhere here. Okay, this means total momentum before collision and total momentum after collision are equal. Okay, so that means that if no external force act on it. Okay, next. Okay, two. How does the graph show the momentum conserved? Okay, so we notice that if we find the total momentum before, okay, let's say, if we find the total momentum before and total momentum after. Momentum before is 12, negative 12. After collision, negative 12 and 12. That means that we notice that the total momentum before, how does the graph show the momentum conserved? Okay, so how is show that conserved? That means that P total before equal to 12 plus negative 12 equal to 0 kg ms negative 1. P total after equal to negative 12 plus 12. So still equal to 0 kg ms negative 1. Okay, so that means that how does the graph show? So the graph show you before the collision, total momentum before collision and total momentum after collision are equal. And see, are the total momentum, are the total velocity of the trucks the same before and after collision? So total kinetic energy, you see, total. That means that before equal to 0, right? 0, okay, before will be equal to 0 plus 0, still equal to 0, okay, 0 joule. So because why? Because the kinetic energy 1/2 mv squared is equal to 0. That means that 0 plus 0 still equal to 0. So that means that at the total, okay, velocity of the truck at the same before and after the collision. So it is yes. Okay, if total velocity, okay, sorry, C is the total velocity. Total velocity, we look at here, velocity, move with, okay, 4 V total before. That means 4 plus negative 4 equal to 0 ms negative 1. V total after will be equal to negative 4 plus 4. So still equal to 0 ms negative 1. Okay, so C is, answer is yes. D is the velocity a conserved quantity in all collision. Is it in all collision? No. Okay. Total velocity not conserved. Okay, but the total kinetic energy conserved. Okay. So we cannot set that velocity conserved. we just can say that total kinetic energy conserved in total kinetic energy is conserved for the perfectly elastic collision. Okay. So question number 2. Is the kinetic energy conserved a quantity? So that means that kinetic energy conserved quantity in elastic collision. In the inelastic collision is no, but for the perfectly elastic collision, yes. So let's walk up for the next slide. Next worksheet. Okay, for lesson 11, comparing various types of collision. Okay, so let me. Okay, this is a velocity time graph for a collision of two graphs. So before collision is V1 is 2 and with the initial stationary trolley of M2. After collision, both move with the same speed of 1.5 ms -1. It is a perfectly elastic collision. Okay, perfectly or not perfectly, we must find out the kinetic energy. Okay, so 1.1a. A E total. Okay, that means that kinetic EK total. Okay, total kinetic energy before collision, it will be equal to M1U1 plus M2U2. So that means that 3 times 2 plus with 1 times 0. So how much I get? So I get 6 joule. EK total after M1V1 plus M2V2. So that means that, okay, here will be U, yeah, this is U1, U2, I call it U1, U2, yeah. So that means that it will be 2 times 1.5 plus 1 times 1.5. So that means 3 plus 1.5. So it's equal to 4.5 joule. So that means that total kinetic energy not conserved. So it is okay. Sorry. Yes. Okay. Okay. Forget 1/2 M1U1 square 1/2 M2U2 square kinetic energy. Sorry. Thank you very much. 1/2. Okay. Times with 3, 2 square 1/2. Okay. 1 square. So 1/2 M1V1 square. So 1/2 M2V2 square. So this will be 1/2. Okay. So this means that 3 Okay, 3, still 2. Okay. Okay. So that means that 1.5 square. One over 2, 3. You want to use E to calculate the, okay, yes, you can. Okay, so that means that we notice that both of the kinetic energy are different, right? So it is inelastic. Okay. So if we use E, E is equal to, okay, E is equal to negative V1 minus V2 over U1 minus U2, right? If we use E. So that means that negative, how much? V1 minus V2. Okay, V1, that means 1.5 minus 1.5 over U1 is 2 minus 0. So that means that we will get that it will be E is equal to 0, right? 0 divided by anything still equal to 0. So if E equal to 0, okay, that means less than 1, right? So E is not equal to 1, that means it should be inelastic collision. If we get E equal to 0, that means E less than 1, so it will be the, okay, inelastic collision. Okay, so next question. Let's move to the next question. B. Is momentum conserved in elastic collision only, or in the elastic collision only, or in all collision? So easiest, we said that write a sentence to explain the difference between the inelastic and the elastic collision. So we